What are Lewis symbols? Lewis symbols are nothing but atomic symbol along with valence shell electrons. What is Lewis symbol? Atomic symbol along with valence shell electrons. That combination is called as Lewis symbol. Okay. Now what is the symbol for hydrogen atom? H. Okay. H. Now if I write one dot over it, what this dot represents? It represents valence shell electrons. In the valence shell, that is in the last shell of hydrogen atom, how many electrons are present? One electron is present. That is shown in the form of a dot. So this is called as the Lewis symbol for hydrogen. Okay. Next, if you take lithium, lithium atomic symbol is Li. How many valence shell electrons are present in lithium? See, what is the electronic configuration of hydrogen? 1s1. One valence electron is present. Lithium 1s2, 2s1. This is the valence shell. Second shell is the valence shell. First shell, second shell. Two shells are there, electron shells. Last shell is the valence shell. First shell is close to the nucleus. Second shell is far from the nucleus. How many electrons? One electron is present. Now you put that electron in the form of a dot. This dot represents the valence shell electron. Okay. Next you have beryllium. What is the electronic configuration of beryllium? 1s2, 2s2. How many valence shell electrons are there? Second shell is a valence shell. There are two valence shell electrons. That two electrons I will show like this. No matter how you will place the two electrons. Okay. No matter how you will place that electrons. Then boron. What is the electronic configuration of boron? 1s2, 2s2, 2p1. So second shell is the last shell, valence shell. How many electrons it contains? Total 3. That 3 electrons will show in the form of the dots. 3 dots represents 3 valence shell electrons. So this is the Lewis symbol of boron. Carbon electronic configuration 1s2, 2s2, 2p2, 2p2. Second shell has 2 electrons plus 2 electrons. Total 4 electrons, 4 dots we can put like this. Always whenever you write the Lewis symbol of the carbon, you have to show how many dots? 4 dots are only. That represents 4 valence shell electrons. Then what about nitrogen electronic configuration? 1s2, 2s2, 2p3, 2p3. So second shell has total 5 electrons. That 5 electrons will show like this. Students, do you remember what you will call this pair? Lone pair. Lone pair, right? Lone pair means that pair which do not participate in bonding. Why you will call as a lone pair? Because it do not participate in bonding. Means that lone pair, that pair will remain like that only. It will not be used in bonding with the other element, other atom. And what is that? This electron called? Single electron called? That 2 dots is called lone pair. Single electron, what you will call? Lone electron. Lone and electron. One pair electron. Okay. So how many lone electrons are there? 3 lone electrons are there. 1, 2, 3. 3 lone electrons. Okay. Next, oxygen. Electronic configuration 1s2, 2s2, 2p4. Total how many electrons are present? 6. That 6 electrons will show like this. 2 lone electrons, 2 lone pairs. 2 lone electrons and 2 lone pairs. Then fluorine. Fluorine. What is the electronic configuration of fluorine? 1s2, 2s2, 2p5. Because the atomic number of fluorine is 9. 9. Total it should contain 9 electrons. 2 electrons in 1s, 2 electrons in 2s, 5 electrons in 2p. Right? So how many? 7 electrons I have to show now. Out of this. 1, 2, 3, 4, 5, 6, 7. Now in the Lewis symbol of fluorine, how many lone pairs are there? 3 lone pairs. 1, 2, 3 lone pairs. How many lone pair electrons are there? 1, 2, 3, 4, 5, 6. How many lone electrons are there? 1. What is the other name for lone electron? What is the other name for lone electron? This is the lone electron, right? Okay, single electron. Unpaired electron. Either 2 electrons into jodi, pair you will call. It is not paired, no, it is unpaired. It is single, unpaired electron. Okay. Then if you take neon, neon atomic number is 10. So 10 electrons it should contain. So if you write the electron arrangement, it is 1s2, 2s2, 2p6. Second shell has total 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now students, if you take lithium family members, in the periodic table, who is at the top? In the periodic table, who is at the top? Who is at the top in the first group? Hydrogen. Okay, hydrogen below element, lithium below element. So now I will read those elements: lithium, sodium, potassium, rubidium, cesium, and francium. Lithium has how many valence shell electrons? One. Sodium metal, sodium atom also has one valence shell electron. Potassium, one valence shell electron. Rubidium, one valence shell electron. Means same family members, same group members will have same number of valence shell electrons. Is that clear? So if I write like this, Na, how many valence electrons I should show? First I will look to which family it will belong. It belongs to lithium family. Lithium below element is sodium. So like lithium, sodium also should contain one valence shell electron. So I will write like this, Na dot. Potassium, how can I write it? K, potassium. Okay, potassium, how many dots? One dot. Because potassium is present below sodium. Rubidium, how many dots? One dot. Cesium, one dot. Now if I ask you magnesium, magnesium where it lies? Below beryllium. Beryllium kinda untundi. Beryllium, magnesium, calcium, strontium, barium. Beryllium, magnesium, calcium, strontium, barium. Same family members. If beryllium is having 2 electrons in the valence shell, then magnesium also should have how many electrons? 2 electrons in the valence shell. Means Lewis symbol will be same. Just the atomic symbol will change. Electrons will remain same. For the same family members, valence electrons will be same. But atomic symbol will change. Is that clear? If I ask you, what about bromine? Bromine. How many valence shell electrons will be there in bromine? Bromine belongs to fluorine family. Fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. Fluorine has 7 electrons. Bromine also will have 7 electrons. So same representation, Br 1, 2, 3, 4, 5, 6, 7. Am I clear now? Right? So just if you remember hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, you can write the other elements Lewis symbols. Okay, particularly Lewis symbols are important for the S block and P block elements. S block and P block elements, nothing but representative elements. S block and P block elements are called representative elements, or main group elements. What they are called? Main group elements. Okay, now this idea you should have. Okay, now if I take the Lewis symbol help and if I write the molecule structure, then I am going to get a Lewis structure. So Lewis structure contain Lewis symbols. It utilizes Lewis symbols. Okay, first this idea you should have. Then next, students, this general idea you should have. Carbon makes how many bonds? Normally it makes 4 covalent bonds. That point you already know. Okay, 4. What bonds it will make? Ionic bonds or covalent bonds? How a covalent bond will form? How a covalent bond will form? Let us say this is one atom, this is another atom. This atom valence shell electron, this atom valence shell electron, if they share, if they are sharing one electron each, then one bond will form. Like this is a share. Sharing jaragalante atom should penetrate partially into one another. Atoms em kavali? Atoms lo unna orbitals actually. Atom orbitals, valence shell orbitals, they should penetrate partially. The 2 combining atoms, valence shell orbitals, they should come close and partially they should penetrate. Not fully they should penetrate. They should penetrate partially. Then a covalent bond will result due to equal sharing of electrons. Both the atoms should share the electrons equally. Okay. So in the share, this atom is contributing 1 electron. This atom is contributing 1 electron. So 2 electrons are used in making a bond. To make one covalent bond, how many electrons are required? 2 electrons are required. So nothing but now you can say like this, a bond is formed between them. Bond is formed. Okay. So if two electrons are shared by each atom, then 2 bonds are formed. How many bonds are formed? 2 bonds are formed. So to form the 2 bonds, how many electrons are required? 4 electrons, right? 2 bonds, right? If the atoms are using 3 electrons for sharing, each atom 3 electrons, then 3 bonds are formed. So if 6 electrons are there between the atoms, then triple bond will form. Single covalent bond, double covalent bond, triple covalent bonds will form. This is formed due to sharing of the electrons, right? So carbon is making how many covalent bonds? 4 covalent bonds, right? That carbon, in throughout your chemistry course, In different modes, it will use that 4 bonds. Different styles. What are the different styles it uses? 1, 2, 3, 4. How many electrons are present in the valence shell of carbon? Just now you have seen the Lewis symbol now. This one. Four electrons are there now. So one electron it is using to make one bond. One electron it is using to make one more bond. Another electron, one bond. Another electron, one bond. This is one possibility. Next. Two electrons it uses to make one double bond. Another two electrons it uses to make another double bond. One electron it used to make one bond. Remaining three electrons it used to make three bonds. Total 4 electrons are there, no? Remember, to make a covalent bond, what you require? What you require to make the pure covalent bond? What you require? You require the lone pair. You require the single electron. What do you require? You require single electron. Which electrons will participate in bonding? Valence shell electrons will participate in bonding. Valence shell ఏ electrons participate అవుతాయి కోవలెంట్ బాండ్ చేసుకోవాలంటే? సింగిల్ ఎలక్ట్రాన్స్. ఆర్ యు ఫాలోయింగ్? ఇక్కడ ఒక సింగిల్ ఎలక్ట్రాన్ ఉంది, ఇక్కడ ఒక సింగిల్ electrons are used in making the covalent bonds. Okay, right? Only these many modes. Still any other modes? Yes, there are other modes also. What are those ones? This one. How many bonds it is making now? 3 bonds. Means how many electrons it is utilizing? 3 electrons. 1, 2, 3. Actually carbon has how many electrons in the valence shell? 4. Then 1 electron I am not showing there. Assume that it is missing. Assume that it is missing. Means it is removed. It is removed. Due to some reason it is removed. Then due to that removal, the carbon will carry a positive charge. Why a carbon will get a positive charge? Due to removal of one electron. Okay, this is actually what you call as a carbocation. Carbocation is a species, unstable species. It's an unstable species. It exists only for some time during the reactions. It is formed during the reactions. A carbocation will carry a positive charge on its head. A carbon will carry a positive charge on its head. Whenever I say carbocation in the given species, a carbon will carry a positive charge on its head. Why it is carrying a positive charge? Because from the valence shell, one electron is missing. One electron is missing. Okay. Now, if I write like this, say, how many electrons carbon is using? This is 1 electron, 2, 3, 4. Actually, carbon will have 4 electrons. So, what is this electron? This is the additional electron that you are getting. This is the additional electron you are getting. Is that clear? So, carbon is losing the electron or gaining the electron here? Gaining the electron. This is the newly gained electron. So, in the valence shell of carbon, a new electron got entered. Due to that new entry of the electron, carbon will bear a negative charge. Here, carbon is not bearing any positive or negative charge. Why? Because no electron is lost, no electron is gained. Understand? So, it's a neutral carbon you can call. What you can call? Neutral carbon. Here also carbon is neutral. Here also carbon is neutral. Here also carbon is neutral. Am I clear? But here the carbons are not neutral. One is positively charged, other is negatively charged. Now this negatively charged carbon makes the name carbanion. This is the carbanion. Understand? Whole chemistry you take to any level, you will come across these species. Any other possibilities? Any other possibilities in your mind? Very good. There is one more possibility. Two single bonds. Okay, like this, and one double bond. This is another possibility. Here also carbon is neutral or not? How many electrons it is using? One. With one electron, one bond it is making. With another electron, one bond. Another electron, one bond. Another electron, one bond. Is that clear? Then what about nitrogen? Nitrogen has how many valence electrons? 5, no? Nitrogen low. Levy symbol చూడండి. How many valence electrons are there? 5. 1, 2, 3, 4, 5. Right? So to form a covalent bonds, what is required? Single electron or paired electron? Lone pair electron? Single electron. How many single electrons are there? 1, 2, 3. So now nitrogen normally makes how many covalent bonds? 3 covalent bonds. Carbon has 4 unpaired electrons, 4 single electrons. So normally carbon makes 4 covalent bonds. Oxygen has how many single electrons? 1, 2, 2. So normally how many covalent bonds oxygen will make? 2 covalent bonds. Normally. Sometimes it become abnormal also. Normally it makes 2 covalent bonds. Okay, fluorine normally makes how many covalent bonds? 1, because there is only one unpaired electron, single electron. Understand? So using the single electrons, the atom can make covalent bonds, right? Students, you tell me from lithium to neon, this comes under which row in the periodic table? Second period elements. These are what? Second period elements, second row elements, right? Yesterday we discussed that the second period elements will follow octet. Octet. They try to attain 8 electrons in their valence shell. 8 electrons in their valence shell. Now neon, if you take, how many electrons are there in the valence shell? If you count 8 electrons. Because of that 8 electrons, it get what? Stability. Neon is stable. Neon is stable. Because of the stability, it will not ready to participate in bonding. Neon is not making any bond with other atoms or with self. Self to kuda bond cheyadu, vere other elements to kuda bond cheyadu. Covalent bonds is 0. It will make 0 covalent bonds. You don't have any compounds in which the neon is making the covalent bonds. Right? So like neon, these second row elements also try to attain what? Stability. How? By achieving 8 electrons in their valence shell. Now you tell me, students, I told one point also yesterday that in second period elements from lithium to neon, actually lithium to fluorine, if I make a break, lithium to fluorine, these elements will try to attain 8 electrons in the valence shell like noble gas. Neon comes under what? Noble gas. ఈ నోబుల్ గ్యాస్ లాగా 8 ఎలక్ట్రాన్స్ తెచ్చుకోవడానికి కోసం వీళ్ళందరూ ట్రై చేస్తుంటారు. కానీ వీళ్ళలో స్ట్రిక్ట్ గా ఫాలో చేసేది ఎవరు? ఆ 8 ఎలక్ట్రాన్స్ తెచ్చుకోవడంలో స్ట్రిక్ట్ గా ఎవరు ఉంటారు అంటే కార్బన్, నైట్రోజన్, ఆక్సిజన్, ఫ్లోరిన్. Attainment of 8 electrons in the valence shell is called octet. Okay, so octet కోసం ఎవరు ట్రై చేస్తుంటారు? సెకండ్ రో ఎలిమెంట్స్ ట్రై చేస్తుంటారు. They will obey, but strictly who will obey? Carbon, nitrogen, oxygen and fluorine. Understand? These elements generally they deviate. They do not strictly follow the octet rule. Okay, they fail to get octet. Understand? Now you tell me, carbon to get octet, how many electrons it requires? Carbon 4 already there. Still 4 electrons are needed. Okay. Nitrogen,
3,
oxygen,
2,
fluorine, 1. For this purpose only, these elements will make bond. Generally, there are 2 types of bonds: ionic bond and covalent bond. How covalent bond is formed? Due to equal sharing of electrons. If 1 electrons are shared between the atom, one single covalent bond will form. If 2 electrons are shared between the atoms, that is total 4 electrons, double bond, 2 covalent bonds will form. If 3 electrons are shared, 3 bonds will form, triple bond will form. Understand? By doing so, they will get octet, these elements. Okay. Sometimes these elements will lose or gain electrons. Generally, these are non-metals. Carbon, nitrogen, oxygen, fluorine are non-metals. Non-metals, they gain electrons. When the non-metals gain the electron, what is the charge they will get? Negative charge they will get. Understand? These fundamentals you should remember. Now, nitrogen makes how many normal covalent bonds? 3 covalent bonds normally it makes. Okay? 3 covalent bonds. Now, what are the 3 normal covalent bonds? Like this. This is one normal covalent bond. 1 electron, 2, 3, 4, 5. So 2 electrons are not participating in bonding. I will call this pair as what? Lone pair. Okay. Next, nitrogen. It can make bond like this. How many electrons it is using? 1, 2, 3 electrons. It is using to make the 3 covalent bonds. Nitrogen valence shell has how many electrons? 5. Out of 5, 3 it utilizes. So 3 bonds. Then 1 lone pair is remaining. This is one possibility. Next, like this. 3 bonds also it is making again. So these are the different styles of 3 nitrogen bonds that nitrogen can make. Okay. Now there is one more case. Sometimes you will come across like this. Nitrogen sometimes make 4 bonds. Now what is the charge it will carry? Is it neutral? Here all nitrogen is neutral in these 3 cases. Here nitrogen is neutral or not? Negatively charged. Negatively charged? No, it carry a positive charge. Remember, nitrogen is carrying a positive charge. When nitrogen makes 4 bonds, it carry positive charge. Do you have any example? Yes, we have an example. What is that example? NH4 plus, which is called as ammonium ion. Ammonium ion. So if you look at its structure, it will be like this: NH, H, H, H. Okay. Now, there are some cases in which nitrogen can make the 4 bonds, and also it will carry a positive charge. Like this is another case. 4 bonds like this or like this, plus charge. Okay. What about oxygen? Oxygen make how many covalent bonds normally? 2 covalent bonds. There are 2 unpaired electrons, 2 single electrons present. So, 2 covalent bonds. That can be like this. Okay. Total 6 electrons will be there. 1, 2, 3, 4, 5, 6. Okay. So how many lone pairs are here? 2 lone pairs. 2 lone pairs. Also it can make a bond like this. 2 covalent bonds it is making. 2 single bonds. 2 single bonds. Right. This is one double bond. Oxygen here it is making 2 single bonds. Here it is making a double bond. Double bond. Bond paina bond undi. That is double bond. Right? How many lone pairs? Again, 2 lone pairs only. But the style is different this time. Is that clear? Next. Special cases. What happens when oxygen makes 3 bonds? 3 bonds. 3 bonds చేసినప్పుడు ఏమవుతుంది? When oxygen makes 3 bonds, it have a positive charge. Next, suppose if oxygen is making a single bond like this. 3, 4. In this case also, the oxygen is carrying, now in this case, negative charge it is carrying. Negative charge. So these are the most common structures of carbon and nitrogen and oxygen you will come across in the throughout chemistry course. Is that clear? Then slowly you will learn when you will get a positive charge, when you will get a negative charge on an atom, that you will slowly learn. Okay. Now, what are the rules for writing the Lewis structures? Rules for writing Lewis structures. Yeah, what is the first rule? Count total valence electrons in given species. మీకు ఏ స్పీషీస్ అయితే ఇచ్చాడో, న్యూట్రల్ స్పీషీస్ ఇచ్చిండొచ్చు, చార్జ్డ్ స్పీషీస్ ఇచ్చిండొచ్చు, టోటల్ ఎన్ని వ్యాలెన్స్ ఎలక్ట్రాన్స్ ఉన్నాయో మనం కౌంట్ చేసుకోవాలి. ద నెక్స్ట్ వన్, ఆఫ్టర్ దట్ what you will do? Draw the skeletal structure. Yes, draw skeletal structure. This most symmetrical. Then after that, what you will do? When you are drawing the skeletal structure, what you will keep in mind? Which is the central atom and which is the terminal atom? Central atom will be somewhere in the middle. Central atom will be surrounded by what? Terminal atoms. Terminal atoms. Okay. Then next, what you will do? Link central atom and terminal atom with dash. Dash means what? With dash. Okay. Dash means single bond, single covalent bond. How many bonds you have to put between central atom and terminal atom? Only one single covalent bond. Okay, don't put 2, 3, 4, 5, 6 like that. Clear? So link central atom and terminal atoms with single bond. Next, after that, what you will do? After that, what you will do? Okay, for linking the central atom and terminal atom, you are using the electrons from what? Total valence electrons. ఇక్కడ నుంచి electrons వాడుకొని ఇక్కడ నువ్వు bond చేసుకుంటున్నావు. Okay, then the remaining electrons, where you will put? Remaining electrons convert into lone pairs and put 3 lone pairs on each terminal atom if it is a second row element. Remaining electrons you will convert into lone pairs. నీ దగ్గర పాకెట్ లో రిమైనింగ్ ఎలక్ట్రాన్స్ ఉంటాయి కదా, దాన్ని దేనిగా మార్చుకోవాలి నువ్వు? లోన్ పేర్స్ లాగా మార్చుకోవాలి. అండ్ వేర్ యూ విల్ పుట్ దట్ లోన్ పేర్స్? ఆన్ ద టర్మినల్ atoms. How many lone pairs you have to put on each terminal atom if it is belonging to the second row? 3 lone pairs. Fixed now. Decided. టర్మినల్ atom చూడాలి నువ్వు. ఇఫ్ ఇట్ ఈస్ సెకండ్ రో atom 3 లోన్ పేర్స్ ఖచ్చితంగా పెట్టి, ఇంకేం ఆలోచించదు. ఇస్ దట్ క్లియర్? సపోజ్ హాలోజన్ ఉందనుకోండి, హాలోజన్ ఉంటే 3 ఏదన్నా కానీ ఫ్లోరిన్, క్లోరిన్, బ్రోమిన్, అయోడిన్ 3 లోన్ పేర్స్ పెట్టి. ఇస్ దట్ క్లియర్? సో దట్స్ వెరీ ఇంపార్టెంట్. హైడ్రోజన్ ఉంటే లోన్ పేర్స్ పెడతావా? నెవర్ పుట్ ద లోన్ పేర్స్ ఆన్ hydrogen atom. If hydrogen atom is a terminal atom, never put lone pairs on hydrogen atom. Okay. Now after this we'll do examples. Don't worry. So you are counting the total valence electrons in the given species. Then you are drawing the skeletal structure. Most symmetric drawing you will draw. Right? Means when you are drawing the skeletal structure, you will identify which is central atom and terminal atom and put it in symmetrical positions. Then you have to link the central atom and terminal atoms. For that you are using the bonds. One bond means how many electrons? 2 electrons you are using. So that electrons you have to subtract from total valence electrons. Then whatever electrons that are remaining, convert them into lone pairs. If the terminal atom is a central atom, 3 lone pairs you have to convert it. Understand? Put it on it. Next, after that what you will do? Why you are putting 3 lone pairs on second row atom? Yes, second row atoms they obey octet. వాటికి ఆక్టెట్ రావడం కోసం ఏం చేస్తున్నావు? 3 లోన్ పేర్స్ పెట్టు. అలా పెట్టి ఆక్టెట్ వచ్చేస్తుంది. ఆక్టెట్ విల్ బి సెట్. ఆర్ యు ఫాలోయింగ్? దెన్ ఆఫ్టర్ దట్ స్టిల్ ఇఫ్ electrons remains, if still electrons remains, okay, now where you have to put that one? Put it on central atom. As lone pair or lone pairs. ఒకటి లేదా ఒకటి కంటే ఎక్కువ లోన్ పేర్స్ రావచ్చు. 2 ఎలక్ట్రాన్స్ మిగిలితే ఒక లోన్ పేర్ చేసుకుంటాం. 4 ఎలక్ట్రాన్స్ మిగిలితే 2 లోన్ పేర్స్ చేసుకుంటాం. అండ్ ఇన్ పుట్ ఇట్ ఆఫ్ ద సెంట్రల్ ఆటమ్. 6 ఎలక్ట్రాన్స్ మిగిలితే 3 లోన్ పేర్స్. ఆ 3 లోన్ పేర్స్ సెంట్రల్ ఆటమ్ పైన పెట్టేస్తాం. ఇస్ దట్ క్లియర్? నౌ హియర్ వన్ పాయింట్ ఇస్ దేర్. సెంట్రల్ ఆటమ్ కి ఏం రావాలి? ఆక్టెట్ రావాలి. దెన్ యు హావ్ టు చెక్ ఫర్ ఆక్టెట్ ఆఫ్ సెంట్రల్ ఆటమ్. If octet is not satisfied for second row central atom, then take borrow of electrons from terminal atom till octet is achieved. ఎందరూ తీసుకుంటున్నావు నువ్వు? టర్మినల్ ఆటమ్స్ నుంచి ఎలక్ట్రాన్స్ బారో తీసుకుంటుండాలి. అడిగి తీసుకోవాలి. సెంట్రల్ ఆటమ్ ఏమని చెప్తుంది? ఐఎమ్ సెకండ్ రో ఆటమ్, ఐ నీడ్ 8 electrons, ఐ డోంట్ హ్యావ్ 8 electrons అని చెప్పి టర్మినల్ ఆటమ్ దగ్గర ఎలక్ట్రాన్స్ అడుగుతుంది. గివ్ మీ సమ్ ఎలక్ట్రాన్స్ బారో. ఓకే, సో వెన్ బారో ఈస్ టేకెన్, వాట్ హ్యాపెన్స్? ద లోన్ పేర్స్ విల్ బి కన్వర్టింగ్ ఇంటూ మల్టిపుల్ బాండ్స్, ఎక్స్ట్రా బాండ్స్. అంటే సెంట్రల్ ఆటమ్ కి టర్మినల్ ఆటమ్స్ మధ్యలో బాండ్స్ ఏమవుతుంటాయి? పెరుగుతుంటాయి. ఆ బారో జర్నీలో ఏమవుతుంటాయి? సెంట్రల్ ఆటమ్ కి టర్మినల్ ఆటమ్ కి మధ్యలో బాండ్స్ ఇంక్రీజ్ అవుతుంటాయి. ఓకేనా? సింగిల్ బాండ్ విల్ కన్వర్ట్ ఇంటూ డబుల్ బాండ్, double bond will convert into triple bond. Maximum how many bonds you can put covalent bonds between 2 atoms? 3. It's a principle. Okay, maximum you can put 3 covalent bonds between the atom. That is the maximum one. Leave it. Is that clear? Next, final rule. If more than one Lewis structure is obtained, then what you will do? How do you decide? Then final Lewis structure is decided based on formal charge concept. Based on formal charge concept. Okay, you are getting this in the form of notes now. Yes. How many of you are having the formal charge concept idea? You also know, right? Niku idea on the no idea, right? Okay, so what we are doing here, if still any electrons are remain after giving the electrons to a terminal atom, if still electrons remains, keep it on the central atom in the form of lone pair or lone pairs. Lone pair or lone pairs. ఓకే, ఒకటి లేదా ఒకటి కంటే ఎక్కువ లోన్ పేర్స్ రావచ్చు సెంట్రల్ ఆటం పైన. దెన్ ఫైనల్లీ వాట్ యు హావ్ టు చెక్ ఫర్ ద ఆక్టేట్ ఆఫ్ ద సెంట్రల్ ఆటం. ఇఫ్ ద సెకండ్ ఎలిమెంట్ ఇస్ ద సెకండ్ సెంట్రల్ ఆటం, దెన్ ఇట్ విల్ ఫాలో ద ఆక్టేట్. నో, మరి 8 ఎలక్ట్రాన్స్ దాని బ్యాలెన్స్ షీట్ లో రావాలి కదా, దట్ యు హావ్ టు చెక్. సో ఇఫ్ ఆక్టేట్ is not satisfied for second row central atom, then take borrow of electrons from the terminal atom till the central atom get octet, till octet is achieved. Okay, after that, suppose if you are getting 2 or more structures, then what you have to finalize the structure using the formal charge concept. Formal charge concept, right? I will calculate the formal charge. I will calculate the formal charge Fc. What is the formula? Formal charge is equal to valence electrons minus lone pair electrons minus number of covalent bonds. Number of covalent bonds. Okay. Now here, to finalize the final Levy structure, some formal charge rules you have to remember. Okay. The best Lewis structure should have these things. One is low formal charges on atoms. Low formal charges on atoms. Low formal charges means 0, +1, -1. These are considered as low formal charges. Then second one, negative formal charge should reside on a more electronegative atom. మీకు ఇచ్చిన స్పీషీస్ లో ఏదైతే మోర్ ఎలక్ట్రోనెగటివ్ ఆటం ఉంటుందో దానిపైన ఫార్మల్ నెగిటివ్ చార్జ్ ఉండాలి. నెగిటివ్ చార్జ్ వచ్చిన ఫార్మల్ చార్జ్ కలెక్ట్ చేస్తే ఆ నెగిటివ్ చార్జ్ దేనిపైన సూటబుల్, లెస్ ఎలక్ట్రోనెగటివ్ ఆటం పైన కాదు, దేనిపైన ఉండాలి, మోర్ ఎలక్ట్రోనెగటివ్ ఆటం పైన ఉండాలి. సపోజ్ కార్బన్ ఉంది, ఆక్సిజన్ ఉంది, ఎవరు మోర్ ఎలక్ట్రోనెగటివ్? ఆక్సిజన్ పైన మోర్ ఎలక్ట్రోనెగటివ్ ఆటం కాబట్టి నెగిటివ్ చార్జ్ దానిపైన రావాలి. అది పాయింట్, దట్స్ ద పాయింట్. దెన్ థర్డ్ one is the opposite formal charges should be close and like formal charges should be far. Opposite formal charges దగ్గర ఉండాలి, like formal charges దూరం ఉండాలి. That's the point. Okay. So how will you finalize the best Levy structure if you are getting 2 or more possibilities? The best Levy structure should have low formal charges on the atoms, that is 0, +1, -1, it is okay. +2, -2, +3, -3, that is not okay. Those are high charges. Don't see the sign, you see the value. 1, 1, low, either +1 or -1. 2, 2, +2 or -2, that is high. +3, -3, high. +4, -4, high. Understand? So 0 is okay, +1 is okay, -1 is okay. Those are considered as low charges. Then negative formal charge, if you are getting calculation cheste, if formula use cheste negative value ochindi niku, negative minus formal charge you got. That negative charge formal charge should reside on what? More electronegative atom, not on less electronegative atom. Then opposite formal charges, that is plus and minus. Plus and whatever it may be, whether it is +1, -2, whatever it may be, opposite undali, plus and minus. Don't see the value, +1, -1 you are getting, or +1, -2 you are getting. That don't see. Plus minus opposite charges, how they should be? Close unte emoutundi? Attraction aithe emoutundi? Energy decreases, stability increases. Understand? That's the point. And the like formal charges, they should be far. What happens if the like charges are close? They repel, fighting చేసుకుంటాయి. ప్లస్ పక్కన ఉండకూడదు, మైనస్ పక్కన ఉండకూడదు, దూరం పెట్టుకోవాలి. అర్థమైందా? దగ్గర ఉంటే స్టెబిలిటీ పోతుంది. సో ద లైక్ ఫార్మల్ చార్జెస్ షుడ్ బి ఫార్. అండర్స్టాండ్? Okay students, yesterday we have done example for water. Today we will take another case, PF3. What is the name of PF3? Nomenclature ento mandiku vachi ikkada? How many of the students know nomenclature of the compounds? Okay, 2. No. How to read this chemical name? What is the chemical name of this compound? Phosphorus. See what I am writing. First you have to see which type of compound I am writing. That you have to see. There are 2 types of compounds, ionic compound and covalent compound. Ionic compound contain metal and non-metal combination. For that nomenclature is having some rules. Their nomenclature is different from the covalent compound nomenclature. Covalent compound contain what? Non-metals. Phosphorus is a non-metal. Fluorine is also a non-metal. So which type of compound it is? Covalent compound. Covalent compound contains what? Non-metals. Non-metals combination will be there. Okay. So in that, what you have to do? How to do the nomenclature? First element you see. What is the name of that element in the periodic table? What do you call it? Phosphorus, right? Phosphorus. You write like that only. In any covalent compound, generally two non-metals ఉన్నాయి అనుకోండి. Two non-metals ఉన్నాయి covalent compound లో. First non-metal ఏది ఉంటుందో దాని నేమ్ as it is రాసేయాలి. Phosphorus unte phosphorus, hydrogen unte hydrogen, like that. Understand? So this is what? Phosphorus. Phosphorus. First element name as it is. From periodic table you write. Next, second element. Second element name you have to see. What is the second element name here? Fluorine. F is what? Fluorine. Fluorine. Right. Fluorine. Fluorine contains floor stem. This is a stem or root. Stem or root అని చెప్తాం మనం. So you have to take that stem. So I will take the stem. Okay. Floor. Okay. Floor. Stem I wrote. Then that should be followed by the three letters. IDE. Ide. You have to add ide. For first element, name as it is. For second element, you take the element name and take the stem. Stem you will get by practice. Understand? No need to note down. So stem, how to write for every element. Okay. When we are writing the names, you will by default get set. Okay. So floor is a stem followed with the word ide. You have to add. Okay. Now see here. Phosphorus, how many atoms are there? Phosphorus, one. See, for one, you will use the prefix mono. One unte prefix ఏమని యూస్ చేస్తారు? మోనో. ప్రిఫిక్స్ అంటే ఆ ఎలిమెంట్ నేమ్ కంటే ముందు రాసేది. ఫాస్ఫరస్ కంటే ముందు మనం ఏం రాయాలి? ప్రిఫిక్స్ రాయాలి. ఎన్ని ఫాస్ఫరస్ ఉన్నాయి? వన్ ఉంటే ఏమని చెప్పాలి? మోనో. రెండు ఫాస్ఫరస్ ఉంటే బై. మూడు బైనా డైనా? One. What is the prefix for one? Mono. Two. Three. Four. Five. Six. Seven. Hepta. Hepta. Okay. Right. 8. Octa. Okay. 9. 10. Deca. Okay. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay. Now remember, how many phosphorus are there? One means what you will use? Mono. But I did not write mono before phosphorus. First element, if it is only one, actually you should get the prefix mono, but never write mono. If prefix you are getting one element, first element is only one in number, don't write mono, never write mono. But for second element, if you are getting the prefix mono, you should write. Mono అనేది మనం ఎవరికి ఇగ్నోర్ చేయాలి? ఫస్ట్ ఎలిమెంట్ కి మాత్రమే. అండర్స్టాండ్? సెకండ్ ఎలిమెంట్ కి మోనో వస్తే రాయాలి. క్లియర్? నెక్స్ట్, ఫస్ట్ ఎలిమెంట్ టూ ఉంటే, రెండు ఫాస్ఫరస్ ఉంటే వాట్ యు రైట్? డై ఫాస్ఫరస్ విల్ కాల్. మూడు ఉంటే ట్రై ఫాస్ఫరస్. దెన్ ఫాస్ఫరస్, if ఫ్లోరిన్ ఉంది, 3 ఉన్నాయి, వాట్ విల్ కాల్? ట్రై. నార్మల్ ప్రిఫిక్సెస్ యు విల్ యూస్. So what is the exceptional case here? When the first element, if it is only one in number, don't use the prefix mono. Understand? For that I will take this one. CO. Carbon is non-metal. Oxygen is also non-metal. It's a covalent compound or ionic compound. Mickey Mouse. Carbon, oxygen. What they are? Metals or non-metals? Non-metals. What type of compound it is? CO. Ionic compound or covalent compound? It's a covalent compound. Non-metals will form covalent compound. Right. Now what is the name you are expecting? For this one, how many carbons are there? 1. Will you use the prefix mono now? No, you will not use mono. Then what you will write? Carbon. Okay. Then what is O? How many are there? 1. Mono is used or not? Yes, you are going to use mono. Okay. Now one more point. Prefix ending Okay, prefix ending is what here? O. O. And the second element name starting, if they are same. Prefix ending and the second element starting, if they are repeating, same, then write only one time. Mono, what O is called? Actually, O is called what? Oxygen. What is the root? Ox. Ox is a root or stem. So you write ox, ox, followed by the word ide. Now the prefix last letter and the second element first letter, it is same, O. So don't write two times O. One time you will write, that's all. Okay. Now the name of this compound is carbon monoxide. If you are getting AA, you will write only one time. AA వచ్చినప్పుడు one time, O వచ్చినప్పుడు one time రాసుకోవాలి. అది ఫాలో. So now what is the final name of this PF3 called? Phosphorus trifluoride. Phosphorus trifluoride. Phosphorus trifluoride. Now what is the central atom in phosphorus trifluoride? Yes, central atom is phosphorus. Fluorine is terminal atom. Now rule start. Count the valence electrons. How many phosphorus are there? One phosphorus and three fluorines, right? One phosphorus, how many valence electrons? Now phosphorus comes under which family? Nitrogen family. Nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen has how many valence electrons? 5. Phosphorus also 5. So 5. Then what about fluorine? Fluorine 7. Yes or no? 7 valence electrons. How many fluorines are there? 3 into 7 valence electrons. Now this comes to 5. This comes to how much? 21. So if you add, you are going to get 26 total valence electrons. Now this many electrons are there in my pocket. Next, what I have to do? Draw the skeletal drawing. Phosphorus we will put in the middle. 3 fluorines you have to put in a symmetrical fashion. Symmetrical fashion until like this you will put. No, that's wrong. Now you can see the symmetry. ముగ్గు వేస్తున్నప్పుడు అందంగా వేస్తారు ముగ్గు, ఎవరన్నా అవునా కదా? మీ ఇంట్లో మీ మమ్మీ ముగ్గు వేయమని చెప్తే మీరు వికారంగా వేస్తారనుకో, తంత మీ మమ్మీ ఎవరైనా అందంగా వేయడానికి ట్రై చేస్తారు. సిమెట్రిక్ డ్రాయింగ్. ఓకేనా? ఒక పక్షి వేస్తున్నారనుకో, ఒక కన్ను ఇక్కడ పెడితే ఇంకో కన్ను ఇక్కడ ఎక్కడ పెట్టింది అనుకో, తంత మీ మమ్మీ ఒక కన్ను ఇక్కడ పెడితే ఇక్కడ ఇంకో కన్ను ఇక్కడ పెట్టాలి. మనకు కూడా దేవుడు ఎక్కడ ఇచ్చాడు? 2 కళ్ళు పక్కన పక్కన ఇచ్చాడు, సిమెట్రికల్ ఇచ్చాడు. అండర్స్టాండ్? మన చేతులు 2 పక్కన పక్కన సేమ్ పొజిషన్ లో ఇచ్చాడు, అవునా కదా? ఒక చేయి ఇక్కడ పైన, ఒక చేయి కింద ఇస్తే ఎట్లా ఉంటుంది? మనం వికారంగా ఉంటాం, అవునా కదా? ఫింగర్స్ కూడా ఎంత మంచిగా ఇచ్చాడు చూడండి. మిడిల్ ఫింగర్, మధ్యలో పెద్దోడు ఉన్నాడు, పక్కన చిన్న చిన్నోళ్ళు, ఇంకా పక్కన చిన్న చిన్నోళ్ళు. ఈవెన్ ఇఫ్ యూ టేక్ లీవ్స్, ఆకులు చూస్తే ఎట్లా ఉంటుంది? మీకు అందంగా ఉంటాయి. లీవ్స్ తీసుకుంటే మీరు చూసారు లేదో, నేను బయాలజీ స్టూడెంట్ కాదు, బట్ ఐఎమ్ టెలింగ్. చూడండి ఎంత మంచి డ్రాయింగ్ ఉంటుంది. ఇక్కడ ఒక లైన్ వీన్స్, వాట్ విల్ కాల్ దెమ్? వీన్సా? ఇక్కడ వీన్ ఉంటే పక్కన ఇట్లా వీన్ ఉంటుంది, మరి ఇక్కడ ఉంటే పక్కన ఉంటుంది, అవునా కదా? ఇవి లేకపోతే వీన్స్ ఒకటి ఇక్కడ అన్ని ఒకటే సైడ్ ఉంటే ఎట్లా ఉంటుంది? కారంగా ఉంటుంది. సిమెట్రీ, నేచర్ ఆల్సో లవ్ సిమెట్రీ. సిమెట్రిక్ డ్రాయింగ్ అనేది ఉండాలి, ఓకేనా? సిమెట్రీ అనేది ఉండాలి. ఇక్కడ వచ్చే ఉంటే ఇక్కడ వచ్చే ఉంది, లేకపోతే ఎంత ఆక్వర్డ్గా కనిపిస్తాం మనం. దేవుడు మనకు సిమెట్రీ ఇచ్చాడు, మన బాడీ సిమెట్రికల్ గా పెట్టాడు. థ్యాంక్ గాడ్. 2 కిడ్నీలు పెట్టాడు, ఒక కిడ్నీ పెట్టలా. డోంట్ ఆస్క్ మీ సార్, 2 గుండెలు పెట్టలేదు కదా సార్. So symmetric drawing. Next, after that, what you have to do? You have to link the central atom and terminal atom. How many bonds you have to put them? 1, 1, 1. Total how many electrons I am using? 6. Each bond 2 electrons means 6 electrons. ఇది ఎక్కడి నుంచి ఖర్చు అయిన ఎలక్ట్రాన్స్ బాండ్ చేయడానికి? జేబుల నుంచే కదా. టోటల్ 26 లో నుంచి నేను జేబులో నుంచి 6 తీసుకొని బాండ్ చేసుకున్నా, ఓకేనా? సో 26 minus 6, what are you getting? 20 ఇప్పుడు నా దగ్గర ఇంకా పాకెట్ లో ఉన్నాయి. ఈ 20తో నెక్స్ట్ ఏం చేయాలి? వాట్ హ్యావ్ టు డూ? సో ఈ 20ని నువ్వు దేనిలో కన్వర్ట్ చేసుకోవాలి? లోన్ పేర్స్, ఓకేనా? టర్మినల్ ఆటమ్స్ ఎవరున్నారు చూసుకో. సెకండ్ రో ఎలిమెంట్స్ ఏం రావాలి? ఆక్టేట్ రావాలి. ఇప్పుడు ఈ ఫ్లోరిన్ దగ్గర ఎన్ని ఉన్నాయి? 2. ఈ ఫ్లోరిన్ దగ్గర 2, ఈ ఫ్లోరిన్ దగ్గర 2 ఉన్నాయి. ఎన్ని రావాలి నాకు? 8 రావాలి టోటల్. ఆక్టేట్ అంటే 8 అంటే 2 ఉన్నాయి ఇక్కడ. ఎన్ని కావాలి? ఇంకా 6 అంటే ఆ 6 నేను 3 లోన్ పేజ్ గా కన్వర్ట్ చేస్తా. అంటే నేను డైరెక్ట్ గా ఏం చెప్పేసిన నీకు రూల్లో? Convert the remaining electrons into 3 lone pairs and put it on the terminal atom. Okay, so phosphorus, fluorine, 1 lone pair, 2, 3, 1, 2, 3, 1, 2, 3, direct. Okay, సో బై డూయింగ్ సో హౌ మెనీ ఎలక్ట్రాన్స్ యూ హావ్ యూజ్డ్? పాకెట్ లోంచి ఇప్పుడు ఎన్ని ఎలక్ట్రాన్స్ వాడుకున్నావు నువ్వు? ఇక్కడ 3 6 are 18 ఎలక్ట్రాన్స్ యూ హావ్ యూజ్డ్. సో 20 లో నుంచి ఎన్ని ఎలక్ట్రాన్స్ యూజ్ చేసుకున్నావు ఇప్పుడు? 18. ఎన్ని ఎలక్ట్రాన్స్ మిగిలినాయి? 2. దెన్ ఇంకా జేబులో ఉన్నాయి దగ్గర ఎలక్ట్రాన్స్. ఇప్పుడు దీనికి ఆక్టేట్ వచ్చేసింది, దీనికి ఆక్టేట్ వచ్చేసింది, దీనికి ఆక్టేట్ వచ్చింది. వాట్ అబౌట్ ఫాస్ఫరస్? దానికి ఆక్టేట్ వచ్చిందా? ఎన్ని ఎలక్ట్రాన్స్ ఉన్నాయి ఇక్కడ? 2 2 2. టోటల్ 6 ఉన్నాయి ఎలక్ట్రాన్స్. సో ఇప్పుడు ఈ 2 ఎలక్ట్రాన్ నేను లోన్ పేరుగా ఫాస్ఫరస్ పైన పెట్టేస్తాను. ఎందుకు? ఆక్టేట్ వచ్చేస్తుందని. బట్ ఆక్టేట్ ఫర్ థర్డ్ రో ఎలిమెంట్ ఇస్ నాట్ కంపల్సరీ. Strictly we will follow the octet rule. Second row element, but third, fourth, they may or may not follow. Okay, so octet వచ్చేసింది. సో ప్రతి ఒక్కరికి ఏం వచ్చేసింది? ఆక్టేట్ అనేది వచ్చేసింది. ఇస్ దట్ క్లియర్? ఆక్టేట్ వచ్చేసింది. సో దిస్ ఈజ్ యువర్ ఫైనల్ లెవీ స్ట్రక్చర్ ఆర్ నాట్? ఎస్, ఇట్ ఈస్ ద ఫైనల్ లెవీ స్ట్రక్చర్. ఒకవేళ దీనికి ఆక్టేట్ రాకపోయింటే ఇట్ విల్ ఫాస్ఫరస్ విల్ టేక్ ది బారో ఆఫ్ ఎలక్ట్రాన్స్ ఫ్రమ్ ఫ్లోరిన్. ఫ్లోరిన్ నుంచి బారో తీసుకుంటుంది. అండర్స్టాండ్? ఫ్లోరిన్ నుంచి బారో తీసుకుంటుంది. ఓకే, నౌ లెట్ us take CO. Second example, CO. Carbon, what is the name? Monocarbon monoxide, carbon monoxide. CO2, carbon monocarbon dioxide kada? Okay, CO. Now total valence electrons. How many valence electrons are there in carbon? 4 valence electrons. Then oxygen 6 valence electrons. Sum చేయండి ఎంత వస్తుంది? 10 valence electrons వచ్చేస్తాయి. Next what you have to do? Symmetric drawing. ఇక్కడ symmetry అవసరమే లేదు. ఎన్ని ఎలిమెంట్స్ ఉన్నాయి? ఓన్లీ 2. The 2 you can put it anyways. ఓకేనా? ఇప్పుడు ఈ రెండు కళ్ళు నాకు ఇట్లా ఉన్నా ఓకేనే, లేకపోతే నేను ఇట్లా అనుకోండి ఓకేనే, సిమెట్రికలే. So I can put it anyways. So I can put CO like this or I can put CO like this. It's okay. ఓకే, ఇంకొకటి కెమిస్ట్రీలో ఒక అనాలజీ ఉంది. ఏం అనాలజీ తెలుసా? ఆర్గానిక్లో వస్తుంది. ఆర్గానిక్లో చాలా మంది స్టూడెంట్స్ కన్ఫ్యూజ్ అయిపోతుంటారు స్ట్రక్చర్స్ రాస్తున్నప్పుడు. సపోజ్ ఇట్లా రాసాను అనుకోండి నేను. Suppose if I am asking you, these two are same or different? This molecule, are they same or different? Same? Sure. These two are same or different? Same? What is your opinion? Same or different? Different? What is your opinion? Same or different? These two are same or different? Those are molecules. Okay, at least tell me these two, same or different? Same? Same? Now these three are same or different? Not same? That's what I'm saying. They are same. స్నేక్ అనాలజీ. పాము తీసుకోండి మీరు. పాము ఎట్లా ఉంటుంది? ఇట్లా స్ట్రైట్ అన్నా ఉంటుంది, ఇట్లన్నా ఉంటుంది, ఓకే, ఇట్లన్నా ఉంటుంది, ఓకే, ఎస్ ఆర్ నో? లేకపోతే ఇట్లన్నా ఉంటుంది. పాము మారుతుందా? పాము పోయి ఏమన్నా కట్టెపుల్ అయిపోతుందా? క్యామెల్ అయిపోతుందా? కాదు కదా. సో దట్స్ ద పాయింట్. ఇక్కడ పాము ఇట్లా స్ట్రైట్ ఉంది, ఇక్కడ కొద్దిగా వంకర తిరిగింది, ఇక్కడ ఇంకా వంకర తిరిగింది. స్నేక్ అనాలజీ, దట్స్ వెరీ ఇంపార్టెంట్. మోస్ట్ ఆఫ్ ద స్టూడెంట్స్ విల్ డూ ద మిస్టేక్ ఇన్ ఐడెంటిఫైయింగ్ ద మాలిక్యూల్. వేరే అనుకుంటారు, ఓకేనా? రైటింగ్ స్టైల్ is different, that's all. What you are having here? CH3. Next after CH3 what you are having? CH2. After CH3 you are having CH2. After CH3 what you are having? CH2. Then after that CH2. CH3. Arrangement is same. Understand? So but only thing is what there are many twists and turns. Change is what? Twist and turns. It is straight ఉంది, ఇక్కడ ఏమైనా twist and turns are there. అలా చేసే మాలిక్యూల్ మారదు. క్లియరా? ఇది ఆర్గానిక్ లో ఇంపార్టెంట్. ఓకే స్టూడెంట్స్, నౌ లింక్ ద సెంట్రల్ ఆటమ్ అండ్ టర్మినల్ ఆటమ్. హౌ? నౌ వాట్ విల్ డూ? విల్ పుట్ one bond. Okay, one bond means 2 electrons here used. 10 minus 2, what you are going to get? 8. What you will do with 8? Where you will put that 8 electrons? On central atom or terminal atom? What is the central atom? Carbon. Terminal atom, where you will put on? Carbon or oxygen? Oxygen. Second row atom or not it is? Second row atom means how many electrons it need? 8 electrons, octet. But how many electrons it is having? Only 2. So it needs still 6 electrons. 8 you convert into 3 lone pairs. 1, 2, 3. So now like this, you got how many electrons here? 8 electrons. So out of 8, how many dots you have used? 6 means 6 electrons you have used. Still you are remaining with 2 electrons. Where will you put it? On central atom. But central atom, okay. What is the point again? Center. Check the central atom octet. Then check for octet of the central atom. Then if it is not satisfied, what you have to do? Take borrow of electrons from the central atom, from the terminal atom. Right? So now it will take the borrow. One borrow. If one borrow is taken, you got 2 bonds. Now how many electrons carbon is surrounded by? Here how many electrons carbon is surrounded by? 2 electrons. Here carbon is surrounded by 1, 2, 3, 4 electrons. Here 1, 2, 3, 4, 5, 6 electrons. Octet వచ్చిందా? రాలేదు. రాలేకుంటే ఏం చేయాలి? Still ఏం చేయాలి? మళ్ళీ ఇంకొక బారో తీసుకోవాలి. One more borrow. So like this. One more borrow. Now how many electrons carbon is surrounded by? 1, 2, 3, 4, 5, 6, 7, 8 electrons. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. 3 bonds means 6 electrons. 6 and these 2 electrons. Total 8. Both of them is getting the octet. So this is your final Lewis structure.